So we want to find the solid enclosed by the cylinder x equals y squared and the plane z equals 0, z equals 4, and x equals 9. Well, let's draw as little as we have to. Okay, so this is going to be my positive x, positive y, positive z. X equals y squared. In the xy plane, what is that? Sideways parabola, yeah. So I'm thinking if I go to 3, positive and negative on the y, I'm going to get to where I want to go here. So remember, this in the xy plane is just a parabola that opens sideways. Vertex at the origin. So vertex, I'm just drawing the curve right now. And then if you plug in 3 for y, you will get 9 for x. Isn't that amazing? You can oftentimes think of it in terms of, okay, what am I given? Is it going to work out nice if I, what would I have to plug in for y so that I get 9 for x? That sort of thought process. Because these are meant, even though it doesn't seem like it when you first learn it, these problems are meant to be user-friendly that way. So 9 on the x-axis, I'm not going to put in 9 hash marks. I'm just going to say, hey, it's right there. And so if you plug in 3 for y, it'll go, at least in the xy plane, it'll go about here. Negative 3, somewhere over here. And probably didn't go out far enough that way, actually. So maybe like that. And then you get this parabola. What does that look like in space? Cylinder, right? You translate that generating curve parallel with the z-axis. But let's see if we can avoid that, right? So, so z equals 0 would be the floor, wouldn't it? Z equals 0 would be the floor, but it's got to be caught inside the generating curve, right? And then z equals 0 is the floor. Z equals 4 would be the ceiling, wouldn't it? So z equals 4, I don't know if I want to attempt to draw that, but that would be just a horizontal plane, right? Maybe I should use a different color. That would just be a horizontal plane, maybe coming out like that. See, it's looking worse because I decided to draw it. So I'll erase it in a second, but it would be that on top, right? That would be the roof. Now I'm going to erase that because it looks horrible. Okay, but you know that the roof, so the floor goes from, say, here to the ceiling, which is at a height of 4, right, up here somewhere. Z equals 4, and that's a plane, so it goes back to, but if you don't draw all of it, it'll look better. Right, so there's part of your ceiling anyway. So I think we have enough information to set up this integral, right? That's one hit with horizontal planes. Draw as little as possible, not too much, and it won't look as bad. Okay, so, I do usually want to see R, although it's pretty much laid out for you in the picture I've already drawn. X, Y, so real quick sketch. R goes like this, right? And then it's cut off at 9, isn't it? X equals 9. So R is in here, right? That's the R. Okay. Now, the reason you want to draw R here is it tells you how to set this thing up. Okay, so I don't think there's any mystery about the inner limits of integration. So if we set up a triple integral here, and we're looking for volume, the integrand is one that we're given the floor and the ceiling in terms of z, right? I don't think we want to mess with that. So what does z go from? 0, this height, to 4, this height. So that's no problem. But here's where you have to decide between dy dx or dx dy? Which way makes sense here? And it breaks down to asking vertical or horizontal rectangles. Definitely horizontal. Definitely horizontal. Look how horizontally simple that is. I suppose it's vertically simple too. It's just you'd have to solve, what's the equation of this curve in red here? It's x equals y squared. If you set it up with respect to vertical rectangles, you'd have to solve for y in terms of x, get plus or minus square root of x. It'd be messier. So leave it as is. And that would correspond to which differential order? I heard somebody say it. Not dy dx, but dx dy. Okay, and then to get the middle limits of integration, what does x go from? The parabola, which is what? Y squared, to just the constant, 9. So think left to right on that horizontal rectangle to get your middle limits of integration. And then think down to up, constants, to get y. What does y go from? So think about this intersection point and this intersection point. Yeah, we already said earlier in our picture that this x-coordinate of this point was -3. X-coordinate of this point is +3. Yes. In this case, since you're finding volume, yes. So you could make it 0 to 3, but then you have to multiply by 2, right? Yeah. Another thing you could do is find just the area in the xy plane using techniques from Calc 1 and multiply by that constant height of 4.